Okay, so a polygon is a many-sided closed figure made up of straight lines that don't intersect. So when we're looking at our A, B, C, D, and E, A is a yes, B is a yes, C was a yes, D was a no, because we've got this nice little ice cream cone thing going on. And E is a maybe. No, because it has an intersection point right here, and it says don't intersect right in the definition. So once you get called a polygon, hey, you polygon, there's two different types you can be. You can be convex, which means that no line that contains that side of the polygon goes through the interior of itself. Okay, let him know. Thank you. So, if you are convex, you are like B and C. So, no line, when you extend it, will go into your shape. So, if you look at A is actually concave, because if I extended this line, it would go into the shape. So if any of your lines, when you extend them, end up inside your figure, it's a concave. And yesterday we talked about being concave, and if it has, your shape has a cave in it, so I can go camping in here. I want you guys to, this little fire. If you can make a fire in it and get shelter, it's got a cave, then it's concave. And our fancy definition of concave is not convex. Any questions? Preguntas, this is just a review of what we did yesterday. Any questions? All right, so now A and B, we're determining, is it convex or concave? A is concave because it has the little caves in here, right here, and then this little cave right here. So this is concave. B is convex because if I extended all these lines out, none of them would cross through the interior of the polygon, so this gets to be convex. And the way I remember it is it's concave, and if it has a cave, if it doesn't, it's the other one, convex. All right, so now we're going to be naming our polygons. You guys have this diagram on your paper. I'll make sure that I write big enough so that you guys can see it from your seat. So a three-sided polygon is called a triangle. Yeah. Triangle. A four-sided polygon. There is a more generic version of square. It's a quadrilateral. Okay. What is the vehicle called? It's an all-terrain vehicle. It's got four wheels. It's called a what? Quad. Because quad is the root word for four. So a quadrilateral is like a triangle. Tri means three, quad means four. So quadrilateral, Quadrilateral. 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 Quad for four. And lateral for the rest of it. And lateral usually means sides. What does a lateral play? in football?
Sideways.
No, it's a sideways. It's sideways. Anyway, 5. Our defense department is housed there.
Hexagon.
Defense department. Heptagon. Pentagon is a 5-sided figure. Now this is for my Wiccan out there. What is a 6-sided figure?
Yeah.
We're gonna put one on our family.
Is the hex?
Yes. Hexagon. Hexagon. 7-sided figure is a
That's 8.
septagon.
No, sorry.
And septagon.
That's what's called
Septagon. I don't know why.
Reminds me of like
Septuplets. Septuplets is 7 tuplets. 7 kids.
Octagon.
Hexagon is a octagon. Octagon now. Okay, 9 has 2, and both of them show up in your practice. Both of them, a 9-sided figure has 2 names. I don't know why there's 2, but there is. So I will give you the easy one first. Nonagon. Or an enneagon. Enneagon.
Which one is the way you pronounce it?
Enneagon. Yeah.
I've always learned.
The fact that I know it.
There's 2 different.
Yeah.
Joseph?
I don't know.
Who made only 3 bits? Judge yourself. Don't be a jerk.
Those who have gone
Joseph.
way earlier than
Nonagon?
Nonagon.
Not a cool phrase.
Enneagon.
Sounds like a
Right. Next one is a Decepticon. Just kidding.
No, I'm writing that
Not. Okay. What? Think about this. What is 10 years called? A decade. So this is a decagon.
Close enough to Decepticon.
Decagon, right? It's like the Decepticon one. They come back every 10. You get a new Transformers movie every 10 years. Mark Wahlberg never ages.
There are only 10 Transformers. I thought it was Decepticons. Trial available.
A 12-sided figure. This one is a fun one. It has no. What is 2 in Spanish? Dos. And what's
Dodecagon.
10?
Oh, I remember this one because it's the
Yeah, 10. What's a 10-sided figure? So think about this. What's a 10-sided figure?
Decagon.
Decagon, and then
Dodecagon.
plus 2. So work with me here. So 10 plus 2 is 12. So what's the Spanish word for 2? 21. Dos. So the dodecagon is a 12-sided figure. So it's like dos, like 2, dodecagon. Dodecagon. So it's like 2 plus 10. And then when we get past 12, we just say whatever the number is, and then do a G-O-N at the end. N-gon, like a 24-gon, or a 100-gon. Decepticon.
I'm gonna Sextagon. Isn't that 16? No. No, that'd be 16. It's a 16. It's a 16.
All right, I want to I want to go to the next page, but I want to make sure you guys have this written down.
I did it. Is that you?
Mm-hmm.
Really?
Mm-hmm. Look at my bowl haircut. It's pretty hilarious.
Why you cut your hair like that?
I had a perm, so it was that, and then a perm, and then a perm.
This is scary.
What are you talking about?
All right, so if a polygon is equilateral, remember lateral means sides, equal means equal sides. Equilateral means all sides are equal. Joe, did you have a question?
Yeah, Joe.
No, Ashley, did you have a question, hon? I'll make it bigger. So equilateral is all sides are equal. Equiangular, angle means angles. Angular means angles. Equa means equal. So equiangular means all angles are equal. All angles are equal. And then when you are regular, doesn't mean you go potty at the same time every day. It means that all your angles and all your sides are equal. I would like you to highlight the word regular and its definition, because you guys are going to encounter it, and because I don't know why, but there's some weird mental block with the word regular. In the explanation, it's going to say a regular hexagon, and because it's the word regular, your brain just skips over it, and you go, Miss Applegard, there's not enough information on this for me to solve the. All right, so we're going to label these equilateral, equiangular, regular, or none. So this shape right here, it's not a square because all the angles aren't the same. This is a big fat angle and this is a big skinny angle. But all the sides are the same. So what does this get to qualify as? This shape right here. Equilateral, are all sides the same?
Yes.
So all the sides are congruent, so it's equilateral. Oh, giant. Boop. All right, this shape right here, all the angles are congruent and all the sides are congruent. So this one is, it is equilateral. That takes care of the sides. It's equiangular. It says, tell if the polygon is equilateral, equiangular, regular, or none, and it technically qualifies for these three. Equiangular. I used an A instead of an I. Equiangular. Okay. And then it's also regular. Right, but it's like saying a triangle is an equilateral triangle. It also qualifies as isosceles because two sides are congruent, so it gets to be isosceles and equilateral. When it's asking you, if it says list the most specific, then you can get rid of the other ones. If it's just saying tell if it's equilateral, equiangular, regular, or none. What about this guy? Does it have all sides, all angles, all sides and angles, or none? This is none. None. What about this guy? All angles, all sides, all angles and sides, or none? It has two sides that are congruent.
Regular.
So all sides and all angles are congruent if it's regular. It does not, this side right here is not the same as this side, so it doesn't get to be equilateral.
So it would be none.
So technically it's none.
Everything.
All right, here's the good stuff. Here's where we're winning. So go ahead and highlight this theorem. So you can do that by circling it. You can put a star next to it. You can put 2 stars, 1 on each side. Theorem 6.1 says that the sum, so that makes a big difference, the sum of the interior angles, which is the pen, in any polygon is going to be the number of sides minus 2 times 180. The number of sides minus 2 times 180. The way I remember this formula is I go back to the triangle. What is the sum of all the angles inside of a triangle? 180. How many sides does a triangle have?
3.
3. What do I multiply 180 by to get 1? I have to multiply 180 by to get 180.
1.
Right. So 3 minus what is 1? 2. So the formula always is n minus 2 because I know the triangle one. We memorize that the sum of the interior of a triangle is 180. So it has to be 3 minus 2. So that minus 2 is for everything. If I have a quadrilateral, it would be 4 minus 2. If I have a hexagon, it would be 6 minus 2. If I have an enneagon, it would be 9 minus 2. And then times it by the 180. So here is where we do the work on this. Find the measure of angle Q, right here, and angle R. So this is a 4-sided figure. So n is equal to 4. So it's going to be 4 minus 2. Figure out what that is and times it by 180. 4 minus 2. Oh my goodness, too difficult for our brains, right?
6.
4 minus 2 is 2. Good job. And then 2 times 180. So if I turned in a half a circle and then turned in a half a circle again, I would get 360 degrees all the way around. Okay, so all the angles inside this angle add up to 360. So that means x plus our 2x plus our 80 plus our 70 all add up to equal 360. So that means 2x plus 1x is 3x. 80 and 70, well, I know 8 and 7 is 15, so 80 and 70 have to be 150. Then I'm going to subtract 150 from both sides. So 3x's is equal to 210. Oh, I know this one without even a calculator. This is awesome. Divide both sides by 3. I don't know what 210 divided by 3 is. I know 21 divided by 3 is 7. So 210 divided by 3 has to be 70 degrees. The measure of angle Q is 70. I have not answered the question all the way. So the measure of angle R is equal to 2 times 70. Which is 140. Boop. Please remember that when you're talking about angles, you put the little angle marker in. Some of you guys missed that on your chapter test, and it was really making my heart sad. All right, so we need to find the sum of the interior angles of a heptagon. 1, 2, 3, 4, 5, 6, 7. Oh, that's another name for a 7, a heptagon. Let's go put that on our list. Septagon, also heptagon. Like a helicopter. Add that to the list. Heptagon, septagon. We want a heptagon. Okay. Add heptagon to your list of 7 sides. Boop. I don't know. I barely made it out of aeronautical engineering alive. Okay, so I counted 7 sides. Thank you, picture, for making a 7-sided figure. So we're going to go 7 minus 2 times 180.
Yeah, we don't have the picture.
You don't? Oh my gosh, draw the 7-sided figure. You want my key for drawing figures?
Sure.
So I kind of start everything almost looking like an octagon. So I go 1, 2, 3, 4, 5, 6, 7. And it's aight. Just do the best you can. Okay, so then this is 5 times 180. Well, I don't know what 5 times 180 is. But I know that 5 times 100 is 500. And 5 times 80 is 400. So 500 plus 400 is 900. Is that what you got, Julian? 900. So the sum of the interior angles is 900 degrees. And the more sides you get, the fatter your angles get and the bigger your sum is. Just gets super fat. More sides, more exploding. Now here's the fun part. When you're asking for exterior angles, so note the difference. This is interior. This one's exterior. So if you're looking at, tell me you have a picture of a hexagon on your page. Okay, let me show you how to draw a hexagon. So you draw 2 parallel lines, one on top, one on bottom. They have the same distance. One on top, one on bottom. Parallel lines. And then you draw a diagonal line coming off of that and a diagonal line, and they meet up kind of in the middle.
You had to draw them?
Yes. It's a 6-sided figure. So exterior angles are what you get when you extend the line out. I should have used a line. Let me use a line. This looks terrible. So when you extend the line out, great. This way, the exterior angle is right here. So imagine that we've extended all these lines out. Oh. We're extending all of our lines out. Then the exterior angle is whoop, these guys right here. Just made a hexagon. So the sum of the exterior angles is always equal to 360. And we are looking at a regular hexagon. What does it mean to be regular?
All sides non-congruent.
Yeah, so all sides are congruent. And all interior angles are congruent. So if all the interior angles are congruent, all the exterior angles also have to be congruent. So we're going to say that the exterior angles is equal to x. And how many of them are there in a hexagon?
5, 8, really simple. 8, 9, 6.
It is 6 on your chart. So we're going to go 6x equals 360. So I have to divvy that 360 up amongst 6 angles. So x is equal to 360 divided by 6 is 60. Okay. All right. That is 6-1. You guys now have practice. You guys have the 6-1 practice. There's 2 pages of that. You have this, or 6-1 reteach. You have the 6-1 reteach, the 6-1 practice, and the 6-1 standardized test prep. It's a reteach and a practice. So you guys are on the hook. You have 1 hour to complete all those practices.